Let's look out at the factors that affect the velocity of sound in air. First one is density. Now we know that after the Laplace's correction, the velocity of sound is equal to root of gamma p divided by rho, where rho is the density, p is the pressure, and gamma is the ratio of the specific heats at constant pressure and constant volume. Now, as is clear, V is inversely proportional to root of density. That means if the density is more, velocity is less. If the density is less, velocity is more. So sound travels faster in less dense gases and slower in more dense gases. Number 2, effect of pressure. Again, taking this formula, V is equal to root of gamma p divided by rho. If the temperature is constant, that means PV is equal to constant. The beauty of the physics is that here it looks that velocity should be directly dependent on the pressure, but we will see the velocity is independent of the pressure. How? Let's look. Gamma p divided by rho is mass per unit volume. This volume gets up, that means root of gamma PV divided by m. Here PV is constant, that means velocity doesn't depend upon the pressure. The velocity of sound in a gas doesn't depend upon the pressure because here PV is constant. Looking forward at the dependence on temperature. As per Laplace's equation, we root of gamma p divided by rho, that is equal to root of gamma p divided by m divided by v. Taking v to the numerator, that is equal to root of gamma pv divided by m, and that is equal to gamma RT divided by m. Here mass is constant, gamma is constant, and R gas constant is constant. That means V is directly proportional to root of T. That means if we increase the temperature, the velocity of sound in a gas increases. If we decrease the temperature, the velocity of sound in that gas decreases. That is, sound travels faster on a hot summer day than on a cold winter day. Effect of humidity. Humidity is the presence of water vapors in the air. When the water vapors are present in the air, the density of the air decreases. That means if the density of the air decreases, the velocity is equal to root of gamma p divided by rho. As the density decreases by the presence of water vapor, that is by the presence of humidity, the density decreases. The density of the humid air is less than the density of the dry air. Let rho m be the density of moist air and rho d be the density of dry air. So rho m is less than rho d. Now the velocity is inversely proportional to the density. That means velocity in the moist air is greater than velocity in the dry air. So because of the presence of humidity, the velocity of sound in air increases. So sound travels faster on a humid day than on a dry day. The presence of the wind affects the velocity of the sound in air because the wind takes the medium along with it. Let us discuss the problem as here is the location of the source of the sound, here is the listener. A wind is flowing in a direction at theta with respect to this horizontal line. That means a component of velocity is along the direction of the sound, that is equal to Vw cos theta. So the velocity of sound in air gets added by this Vw cos theta and Vs. So the velocity of sound V-S becomes velocity of sound, that is Vs, and the component of the velocity of wind along that direction, that is Vw cos of theta. Thank you. for your patience.